I've been looking around on the web trying to find good animations of folds and faults, and I found this website. It's called visiblegeology.com, and it's really nice. It has block diagrams that show different types of folds and faults. So if you just type into your web browser visiblegeology.com, visiblegeology.com. You can get to this website, and there's a main page. You click on this button that says Visualize, and then when you get to this page, you go to View Models. View Models. Click on that. You can look at models of different folds and faults. So let's start with the model of the syncline. Remember, the syncline's the trough-like fold. Loads the syncline model and gives you a block diagram, right? Block diagram that you can move around. That's kind of cool. So you can look at the different views of the syncline. Let's look at this view, the simple cross-section view. In a cross-section, you can see that there's a syncline when you see different sedimentary rock layers that have been bent down into a trough or gutter-like fold. That trough or gutter-like fold is called a syncline. And then you can take the model and you can tilt it downward and see how the different rock layers in the subsurface are going to crop out on the surface, or how they're going to look on a geologic map. Up here on the top of the block diagram, we have the map view of the syncline. And what you can see is, in this case, where we have a simple non-plunging syncline, the different rock layers in the subsurface crop out on the surface in parallel bands on either side of the fold axis. This green rock unit up here, it runs right along the fold axis. This imaginary line that would cut the map view of the syncline into two halves, or two limbs as we call them. It's called the fold axis, runs along here. So if we have a cross section that's cut perpendicular to the fold axis, we can see that trough-like shape, and it's easy to recognize this as a syncline. Now if we look at a view of a cross-section cut parallel to the fold axis, we can do that by rotating this around to this side, right? This side of the diagram is parallel to the fold axis. There's a fold axis, and this is a cross-section over here cut parallel to that fold axis. Okay, and like when we see that cross-section view, doesn't look like there's any fold there at all. They're just horizontal rock layers. And that's because this is a non-plunging syncline. In a non-plunging syncline, the fold axis is horizontal. Not tilted at all, it's horizontal. Okay, and for both the non-plunging syncline and the non-plunging anticline, in the map view, we're going to see the rock layers or different rock formations on the geologic map have these outcrop patterns that are parallel bands on either side of the fold axis. That's in the case of the non-plunging syncline or the non-plunging anticline. We'll show the non-plunging anticline real quick. Okay, there's the anticline. We can see is the arch-like fold in the cross-section cut perpendicular to the fold axis. Now we're looking at the map view. There's our fold axis, and the different rock formations in the anticline crop out in parallel bands on either side of the fold axis. Once again, in this cross section that's oriented parallel to the fold axis, the rock layers aren't tilted at all. They're just horizontal because this is a non-plunging anticline. They didn't put strike and dip symbols on the map here. Maybe there's a way to show that. I didn't look into it that far, but one thing you can see from these models is that when you have an anticline rather in the subsurface, you're going to see the oldest rock in the map view crop out along the fold axis, and as you move in either direction away from the fold axis, you see younger and younger rocks in the map view, right, for an anticline. And it's the opposite for a syncline. Right, in a trough-like syncline fold, the older rock layers are brought up to the surface out here on the limbs of the fold. So in the map view of the syncline, you see the youngest rocks exposed along the fold axis. And as you move in either direction away from the fold axis, you find older and older rocks. Now let's look at the plunging syncline. The plunging fold is one where the fold axis is not horizontal, it's tilting. And we're going to see that in this side view cut parallel to the fold axis. So let's go from the non-plunging syncline here to the plunging syncline model. Okay, so here's our cross-section view, with this cross-section being perpendicular to the fold axis. Looks like any old syncline. You can't tell the difference between a plunging syncline and a non-plunging syncline if you're only given a cross-section cut perpendicular to the fold axis. Okay, let's look at the map view. That's where you see a difference. In a map view of a plunging fold, the different rock formations show up on the geologic map as V-shaped bands. Instead of parallel bands, the bands converge and make, or they kind of wrap around and make this V-shaped pattern in the map view. And you can also see the side view here that's cut parallel to the fold axis. That what makes a plunging fold plunging is the fold axis is not horizontal. In this case, it's plunging off to the right here, or if we turn the diagram a little bit more, this syncline is plunging into the screen, right? The fold axis is tilted or plunging into the screen. Still follows the same rule that along the axis of a plunging syncline, you're going to see the younger rocks exposed along the axis, and as you move away from the fold axis, you see older and older rocks. But the V-shaped outcrop pattern in the map view, right? That indicates that it's a plunging fold in the subsurface. Let's look at the plunging anticline. Okay, there's our plunging anticline, and once again, the anticline's axis is plunging into the screen. You can see that really well in the side view cut parallel to the fold axis. Fold axis is not horizontal like this. It's plunging into the screen. And there you see that V-shaped outcrop pattern in the map view. Still having the oldest rocks exposed along the axis of the plunging anticline, and younger rocks exposed along the limbs of the plunging anticline in that map view. Let's tilt it a little bit so you can see that better. Right, this purple layer farther below the surface is an older rock layer, compared to this brown rock formation is a little bit younger. Light brown one is younger still, and younger rocks out on the limbs of the fold. Oldest rock exposed along the fold axis. That's the case for either a non-plunging anticline or a plunging anticline. So maybe if you play around with these block diagrams a little bit, it'll help you visualize what the non-plunging folds and the plunging folds are going to look like, both in the cross-section views and also in the map view. And our lab exercise is going to work with the block diagrams as well.